Hi class. Today is lesson 10-3, area of composite figures. Today our purpose is, let me get the right tool here, is to break apart a polygon into simpler parts to find its area. The next slide shows you that there is no vocabulary for today, so I'm sure that makes you sort of happy. Continuing to the first example, it asks us to find the area of each polygon. Here we have a hexagon, a six-sided figure that's not regular. Now there is no special formula to find area for a figure like this. So we're going to go ahead and break it up into manageable and recognizable pieces. First thing I'm going to do is I'm going to go ahead and draw a line down here that separates this rectangle from this rectangle. And you can see that's been separated right here. We've got a rectangle that is 1 8/10 centimeters by 1 5/10 centimeters. Then we have one here that is 2 centimeters by 1/2 centimeter or 5/10. So what happens next is we're going to go ahead and take the area of each of these rectangles. Here we have the first rectangle. Remember to go ahead and write down the formula every time you calculate area or perimeter or anything that we encounter throughout this unit. Area equals length times width. Now, area, that's area of figure 1, which is this rectangle. So now we're going to say the area of that rectangle is 1 8/10 times 1 5/10. The area of that first figure equals then, well, once I do the math, it's going to equal 2 7/10. 2 7/10 centimeters. Next, we're going to go ahead and tackle the other rectangle. We're going to write down the area, or the formula for area as well. Area equals length times width. In this case, it's the second rectangle. So I'm noting that it is the second. Area of that second figure would be 2 times 5/10. And 2 times 5/10 equals 1. And that's going to be 1 centimeter, and both of them should be squared. We don't need to worry about the labels at this point, actually, because we haven't come up with the answer. But in the end, we're going to add the area of rectangle 1 plus the area of rectangle 2. So now we have a combination of 2.7 plus 1 equals 3.7. Now this is where the label becomes crucial. 3 7/10 centimeters squared. There's your answer. Now for example number 2, I only want you to draw the y-coordinate and the x-coordinate. I don't want you to worry about the blue gridded area. And I know you'll have to stop here to do this. Here we also have to find the area of the polygon. With this particular area, we've got, we can break this thing down into 3 separate rectangles. Now we can do this differently as well. But at this point, I'm just going to go ahead and break it down to these 3 rectangles. So what does that look like when we actually separate them or label them? Well, you have angle or rectangle 1, rectangle 2, and rectangle 3. Armed with that information, we're going to go ahead and find the area of rectangle 1, the area of rectangle 2, the area of rectangle 3. Add them together, and they should give us the entire area for this polygon. So the area of rectangle 1 equals length times width. Here we have, well, this is 2, 4. It's a 4 by 2, 4, 6, 8. So area, number 1, is a 4 by 8. 4 times 8. So the area of number 1 is 32. Notice I'm not going to put square units or anything until the end. Next, I'm going to choose number 2, and number 2 is from 6 to 8, which is 2 square units by 2, 4, 6. So 2 by 6 units. So area, number 2 equals length times width. Area of number 2 equals 2 times 6 units. The area of number 2 equals 12 units. Okay, 12 total. Now, number 3. Number 3 is, well, this is 2, 4, 6 by 2, 4. It's a 6 by 4. Again, we write down the area. Here, the area of rectangle 3 is length times width. Area of rectangle 3, once again, is 2, 4, 6. 6 times 2, 4. Area equals 24. Now, what we need to do is go ahead and add all those separate areas together. Will get us the area of the entire polygon. So area equals 32 plus 12 plus 24. Excuse me. And in the end, that equals 68. We're going to put square units. 68 square units. Let's go ahead and get to our complete the problem. If I can get to that page. Oops. Wrong area. Let me go ahead and lift that up. There we go. To complete the problem. Sorry for that technical difficulty. It was for your amusement. We have a house on its side. It's essentially a pentagon. A pentagon that's not regular, of course. What will that look like if we should break it up? Well, I see a rectangle, and then I see attached to that rectangle a triangle. So let's take a look at it. There's a rectangle, and there's the triangular top. Well, when we combine the area of these two figures, we're taking the area of a rectangle and the area of a triangle. So let's write down those formulas. The area of a rectangle we've worked with already. Area equals length times width. And now the area of a triangle we've just had a lesson on, and that is half base times the height. So let's take a look at what we have in terms of measurements. For this first one, the rectangle, it's an 8 by how long? Oh, it looks like it's 10. Great. Now we have this second figure, the triangle, and right here its base is the same. It's 8. So what is the what's the height here from the base to that vertex? Well, we only have to look up here. If this is 10 and this is 13, you should be able to figure out what that height is. What is that height? There's a question mark. What is that height? You'll substitute those specific measurements into these two formulas, add them together in the end, and they'll give you the entire area of this polygon. All right, we'll see you in class.